So let's look at what are we going to do today. We'll look at what is big data. We'll understand what are the limitations of the existing solutions. Why do we need something like Hadoop? Okay, we'll also understand how does Hadoop solve the problem. Then we will be we'll be looking at we'll be introducing you to Hadoop. We'll look at the various components in the Hadoop ecosystem. We'll also look at the core components of Hadoop, which is HDFS and MapReduce. We'll go into details of HDFS architecture. We will also understand how does the MapReduce job execution work. We'll understand terms like rack awareness. We'll also understand how does a file read and write happen in Hadoop. And then we'll also take a sneak peek on the Hadoop 2.0 architecture. Okay. Okay, so what is big data? Now, I'm sure everyone has heard about big data. Everyone has done their own research on big data till now, and they know what is referred as big data. But let me also tell you what big data is according to me. Now, not very different than what you've thought. It's lots and lots of data. That's what it's called. That's why it's called big. Now, it is not in megabytes or gigabytes when the data reaches terabytes and petabytes. And if the data is really large and complex in the sense that it is not not just structured data, a lot of unstructured and semi-structured data is called big data. And there are a few definitions associated with big data where they say that, okay, big data, when you have large amount of data flowing in your system, okay, at a big speed and a big variety of data like big streams from, if you click on something on, say, a like or a share on Facebook, that contributes to big data. Large amount of videos, audios which are shared is called is big data. The amount of data which is the kind of data which is shared in, say, I mean, the amount of data, the customer data which you get, the kind of customer behavior data which you get in large organizations, that contributes to big data. Why are people so crazy about big data these days? What does big data help in? So yes, so this is basically the motivation about, see, everyone had a lot of data. It's not that data has come today, but there was not many ways of analyzing that data. Okay, so with tools like Hadoop coming in, it has become much more easier to analyze that data. Okay, and you can do predictive analysis, you can do trend analysis, you can look at customer behavior, you can run specific campaigns for customers, you can do say a fraud analysis using big data. So lot of domains are finding applications there. It's all started with social media, but now, I mean, right from banks to retail, we'll be looking at some examples to government. Everywhere people have started realizing the power of big data analytics, and they are doing analytics there. Okay, so now there is an example here which says New York Stock Exchange generates about 1 terabyte of new trade data per day to perform stock trading analytics to determine trends on optimal trades. Now, if you look at 1 terabyte of new trade data per day, and no trade analysis is done based on a single day data, right? It is done based on a data over years or months. So you can imagine the kind of data you have to crunch, and you need to have all that data in single place, and there has to be a tool which can actually crunch such huge amount of data. Okay, we will be looking at so that's the amount of data we are talking about. Now there are various applications, various places where you will find this data. Mostly the data which we deal with when we talk about big data is unstructured data. Okay, so in this section we will be looking at some of the big data customer scenarios. We'll be looking at what are the use cases where people are using big data analytics. Okay, so eBay, for example, is using a lot of it in web and e-tailing, which on eBay, if you've gone there, you'll see a lot of recommendation engines which will say that, okay, the people who bought this also bought this, right? You've seen that, something like that, everyone? Has everyone seen that? If you try to check out something from either eBay or a Flipkart, it will say, okay, people who bought this also bought this. So that recommendation engine is done using big data analytics. In fact, Mahout is the tool which is used on for doing that, the building recommender systems. Okay, I'll talk about Mahout as well, so don't worry about that. Then ad targeting, I've already spoken to you about ad targeting, where on a specific customer you can target your ad based on his behavior. So that's one place where people use big data a lot. Improving the search quality and click fraud detection. So for example, if you have ad on Google and there is someone who keeps on clicking that ad every time using a bot, for example, Google has to make sure that that ad is not charged for. Okay, so even if you go and click a single ad 100 times on Google, it is not that the advertiser will be charged for that. Okay, so that's also done using big data analytics by looking at who is actually doing that. Okay, then in telecommunications there is China Mobile, which is a large. I mean, Airtel also uses that. A lot of Indian mobile companies also use it. In fact, a lot of companies in the US also use Hadoop right now. So for network performance optimization, calling data record analysis, all this call data, for example, is unstructured data. Right? It's audio data. So if you have to do some analysis over that, if you have to look at, okay, and if you have to look at the performance of your value-added services schemes, so you have to analyze huge amount of data. How many people actually got and used that particular top-up plan which you gave, and what was the churn from there? So that is the kind of thing which that is the kind of analysis which we do using Hadoop here or big data analytics. Okay. And you also analyze your network to predict failures. Okay. So we want to know more of our customers. So basically, we want to know the customer behavior, the customer, the kind of, say for example, if I know these many customers actually, these many customers use this kind of schemes. Okay. So what I'll do is that I'll probably introduce a scheme where these customers will be, say for example, let's take an example. Now I have a segment of young customers who use a lot of phone in night, okay, but they are looking at competitors which are giving them free night talk time, okay. So that will lead to customer churn for me if I've not got that data analysis properly, okay. And if I have got that data analysis properly, I'll be able to prevent that customer churn by introducing a scheme like that. Does that answer your question, Vivek? So customer churn prevention is understanding your customer behavior and introducing specific schemes for our customers or a set of customers so that they do not go to competitors. Okay. So these are all the places where in telecom big data analytics is used. Okay. Now you've understood the application of big data analytics in retail. You've understood the application of big data analytics in telecommunications. Okay. So let's see what are the other use cases. Now in banks and financial services, JP Morgan Chase, for example, one of the largest banks. In fact, all the top 5 banks use Hadoop. Okay. In fact, top 3 of the top 5 banks use Hadoop, use the Cloudera Hadoop itself. Okay, so what are the kind of things which they use for Hadoop for? Basically, for modeling true risk. What that means is that you have to look at, okay, with a particular loan or with a particular transactions, what could be the risks associated with it. Say for example, a lot of insurance companies actually use big data analytics. What do they do with it is that looking at your past records in terms of payments and looking at your health records, they'll predict, okay, this should be the premium you should pay, and based on your region where you live, the kind of salary you earn, your premiums will vary and the kind of schemes they can offer you will vary. Okay, so these are the applications in the financial services domain. Okay, now retail. Coming to retail, we will also be looking at Sears. Sears has a very interesting use case. I'll be going into some detail there. Now, point of sales transaction analysis, again, customer churn analysis or sentiment analysis. What does this mean? Okay, so when you go to a retail store, if you go to a retail store and if I know that you had visited me, say 3 months back, and you bought something from me, and at this point of time, I can give you an associated discount on a particular thing. I can, and okay, just hold on, Prem, I'll explain that. Okay, and I can, so I can, if, say I am the person who's selling you, I am the cashier there, okay, you came to me, and I told you, hey, do you know you have a discount on black shoes, because you bought, say, a black suit a few weeks back, and we have a running discount on black shoes, black leather shoes. If I knew this data about this particular customer, and if I know, okay, this customer is most likely to buy something like this if I give him a discount, or say, for example, a customer who is very high on electronics, whenever a new thing comes in, he comes and buys it, and today he has just come to buy something else. If I give him a discount on that, that's something which will really help me in selling more. So that kind of analysis a lot of retail stores do now. Okay, so Prem says, I was working with Deutsche Bank on credit analysis, but we are not using Hadoop. Now, see, it is not just that you will be, all the time you will be using Hadoop. When the data becomes huge and you really want to, I'll show you an example and you will understand where Hadoop will come into place instead of other, let me just go to the next foil, okay. Okay, so this is a case study on Sears Holdings. Sears is a retail store, okay, a mid-sized retail store. Now what they did, what they were doing earlier was that they were using a combination of Teradata, Exadata and SAS to do data mining. Okay, they were using a traditional system like Exadata, Teradata, and to store and process customer activity and sales data. And they wanted to understand how do their customers behave. Okay, now they were not using Hadoop earlier. What were the what did they want to do? What did they want to come up from there? The same thing which I showed you just now in the point of sales. Okay, that they wanted to understand how are their customers buying, what are their buying patterns. Okay, what are their what could be, when do the customers buy, what are the kind of things they're buying, what could be the associated things they can buy if a particular customer is buying something, so that they can offer them deals and discounts, as well as they can map their behavior properly. Okay, so earlier they were using system Teradata, Exadata combination along with SAS. Now there were some issues which they were facing, because of which they shifted to Hadoop. Let's see what was the challenge there. So you can also read at this link why Sears is going all on Hadoop. So this is one link which you can find in this PPT. This PPT will be available in your LMS, so you'll be able to look at this link as well. Now what was the challenge? So basically this is the place where you collect the data from the instrumentation, your point of sale instrument. You collect and you store the data on a grid. Okay, so it will be a huge data which will be stored. Initially what happens is that 90% of their data was getting archived. So after a period of time, this data becomes too huge to handle in this storage grid, and they were archiving this data. I'm sure a lot of you have actually seen a lot of, it's just another, just hold on. Just hold on for some time, you'll get to know what is, this is what I'm explaining you right now. Okay. Okay, so the storage here is a grid of computers where you're storing your data. Okay, this is not Hadoop. Usually the usual your storage area network kind of thing. And what you will be doing on this will be that after some time you will be archiving some data. Okay, at any point of time the active data which is available for processing is around 10% of the data, and 90% of the data is archived. Okay, so you have limited availability of data to analyze. Say for example a customer came 3 months back, you will not be able to look at that data. Archiving refers to putting that some data from an active level 1 storage to a level 2 storage, like a tape, or to a level 2 storage, which is not actively used for analysis. Okay, so you in your offices you would have seen that there will be a tier 1 storage, there will be a tier 2 storage, then there will be, everything will be stored on a tape going forward. and you look at the archive data when only when there is a problem or something goes wrong, you pull that data back to do that. But then the challenge there is that if you cannot store such huge amount of data in an active tier 1 system, and that is why you could analyze only 10% of that data. Now, if you analyze only 10% of that data, because the challenge here was that if you move it to a ETL compute grid, you will not be able to do that because of the limitations there. Now, this data goes into RDBMS, then you run your BIA interactive apps to get basically to get an insight on the customer behavior. Okay, so let me repeat this once again. What is happening here? Here is your instrumentation and data collection. This data is getting stored into a storage network. Then a lot of this data gets this is all raw data. A lot of this data gets archived over a period of time. This data is moved into a ETL thing where you do extract, transaction, load. Everyone understands what is ETL? Okay, so ETL will be used on this raw data. Okay, so we will be reading this raw data, we will be extracting meaningful information out of that data. Okay, and then we will be generating reports out of that based on the business requirements. Okay, so there will be some SQL querying done there. We will be looking at more into ETL as we go into this course, but for now you can understand it this way, that it will be you move the data into a data warehouse, okay, where you will be analyzing this raw data, you will be reading this raw data, and you will extract refined data from this raw data, okay, and then move it into and generate reports based on that. Okay, so the challenge here is that only 10% of the data is available at any point of time to generate interactive reports which can give you insights into the customer behavior. Okay, so that's what Sears was also seeing. And what they did was something like this. So they removed this complete ETL and the storage grid with Hadoop. Okay, now this complete data is available at any point of time to do analytics. Okay, you don't have to archive any data. You can actually put all the data together and do all the analysis together. Okay. Okay, so the challenge which companies face is not about storing that data. The challenge is about retrieving that data at a very fast rate and putting it into a ETL kind of system. Okay, now what happens is that the storage sizes have gone up. They have scaled up beautifully. What has not happened is that the read speed from a storage is not increased. The read still happens at a very low speed. Okay, we will be looking at that in a while. So because of that, it is impossible to read all that huge data without using something like Hadoop. And I'll be telling you why, okay, in a while. So just hold on. Some of these things will become clearer as we move on. For now, you can just understand that with Hadoop, you are now able to utilize your complete raw data for analytics as compared to earlier system where you were using only 10% of that data. Okay. So the performance of getting data and everything we'll be talking about in a while. Okay, you will understand all those things. Okay, is that okay? Is everyone fine with that? So see, the crux which you need to understand here is that because of the limitation of not being able to get that data from a ETL, from a storage grid, okay, we had to archive a lot of data and you could use only some data. Okay, now Hadoop has solved that problem and you have the complete data available for analysis. How is it different from the storage grid is something which we'll be looking at in a while. Okay, we'll be also looking at security in Hadoop, not in this class, but later on, Satish. Okay, so is that clear to everyone, guys? How has Hadoop changed the fact that you can now analyze a larger amount of data as compared to a lesser data earlier?